Wow. What are you doing? Okay. Okay, so read this problem. Isn't this an interesting problem? It's pretty normal.
It's very typical.
Yeah.
I remember there's a name for it. Like, no, I remember the name for the algorithm.
If you say the algorithm, the point is to learn the algorithm, so they have that.
I mean, if I say the name, they wouldn't figure out what it is. It's
No,
just a
they
name.
would.
They would? No,
Yeah.
no, the name is just the last name of the guy.
No.
Yeah,
no,
and combine it together.
No, this is not it. No, this is simpler than I think. Yeah, the thing I think. Well, I don't really know which one you are referring to, but it's not that.
Okay.
This one is very simple.
Technically, you can say it false on. Let me see if I read it wrong.
I think you read it wrong.
Okay, let me read it again. T products. Okay.
Okay, do you guys understand the problem?
Well, they can work simultaneously.
Yeah.
Then don't you just make everything start at once?
Yeah, that's a good idea. Okay, so basically there are these machines and then they can all work at the same time. Okay? And then you will have an array. For example, here 3, 2, 5. That means there are 3 machines. Just 3. And then for the first machine, it can make 1 product every 3 seconds, and the second machine can make 1 product every 2 seconds, and then the third machine can make 1 product every 5 seconds. And
reading comprehension issue.
yeah, and then this one, that means that you need 7 products, and then they're asking you how much time you need to make 7 products. Okay, it's very simple, right?
Pretty straightforward. I just realized I always had a weird reading comprehension problem. Every time I'll read something wrong, and then I'll go back and say, oh, it's quite simple, and then I just do it. I don't know, it happens to me in Chinese as well. I think maybe I'm just bad at language.
Anyway, what are your thoughts?
Any idea? Do you need hints?
Like make all the machines run.
Make all the machines.
How do you want to run? And what time?
So, let's talk about this a little bit concretely. So in this situation, obviously it is best to run all the machines at the same time. And then when a machine is done with a product, you just make it make another product. Like all the machines need to be working at all times. That would be good, right? So, yeah, this is pretty simple and intuitive. But so, like the way you make machines work is pretty simple and intuitive, yes. But the question here is how much time you need to make this number of products. And that's a little bit complicated. I think maybe you could do it using math. It's a little bit complicated though. Let's think about a slightly different problem, okay? Okay, so what if you know how much time you have, okay? You have a set amount of time, and now it is asking you how many products can you make in this amount of time. Okay, now this is a much even simpler problem than this, right? How would you answer that question?
You can just use all the machines and see how many each one produces.
So algorithmically speaking, how would you do that?
Given a time t, and for a machine who has ki, how many products does it make, and overall for each ki, how should you combine them so you can find the
Yes.
number?
5.
Yeah.
T by Ki.
Yeah.
Add them all.
Yeah.
Oh, then can you just like
So you just floor it. You know floor,
Yeah,
right?
floor.
yeah?
Okay.
Yeah, it's
you
by
guys,
default.
You know floor.
You know, ceiling and flooring. Like you divide a number, maybe you have a remainder, right? Flooring, there's ceiling and floor. Flooring means flooring it away. Just keep the whole number. Ceiling is just you
Like
keep
that.
Yeah.
And then that of that equals 3. It's like basically round down and round up, you know.
By the way, rounding down is by default, but do you guys know how to do rounding up mathematically? Using
Huh? What is it?
Okay, say you want a fraction x over y.
Excel.
Not exactly. So for example,
Just for fun information.
1 over
这个是2乘5的意思吗？2除以5。
oh the 2.5. That's what I meant. Okay, say 1 over 4, and then you want to floor this, and then you have this 1, you have this 4. Okay, if you just what happened to this? What is this? Okay, so if you just add 1 to here, that will not really work, right? It will still give you 2. So what you want to do?
0.5 to the product and then,
Add 0.5.
and then make it an integer.
Add 0.5. But then this will be 3 over 5. That's not the right answer, huh? Why are you so bad at math? That's an issue, right?
I mean, and then make the answer an integer so
But then
it rounds down again.
but then that will give you 0. But we want 1.
We're trying to floor or seal right now.
We were trying to seal.
Yeah.
Because automatically,
Oh,
You need to have some hints. Or do we just say it?
it's okay, huh? Okay, so the one that you thought of is probably thinking about when you are dividing by 2,
Yeah.
right? So like for 1 over 2, then if you add 1 to the top, you will get 2 over 2, which will get you the correct answer, which is 1. And then if you have 0 over 2, then you will get like 1 over 2, and you get 0, which is the correct answer. That's probably what you're thinking of, right? And then if it's 2 over 2, then it will become 3 over 2, and then that will still be 1, which is very correct, right? That's what you're thinking of. Yeah, okay. But now let's think about 3, okay? 1 over 3, and you want, and then you want the answer to become 1, but for 0 over 3, there's some stuff happening over here, and then you want it to become 0. Okay, what do you want to do with it? How do you make this the result? How do you make this result happen? And then the same with 0 over 4, right? Yeah.
Check if it's divisible.
Check if it's divisible. Okay, and then
If it's not, then add 1.
if it is
Result.
if it is not divisible, then add 1 to the
By
result.
mod and stuff. I mean, you
All
can,
right.
You can do that.
You can do that, but you should know that this mod is very slow. It is like 10 times slower than multiplication. Is it? Wait,
10 times.
I think it's around 10 times. 10 times slower than add, or 10 times slower than multiply? Huh. Basically, it's slow, okay? Mod is slow. So you should not do that if you have the choice. And in this situation, you do have a choice.
Think about a mathematical formula, and that computers, by default, how do they handle division with integers?
So you will want this 1 over 4 to be, okay, say that you know that the remainder is 4. Sorry, divisor. Divisor is 4. And you want this to be the lowest number to get a 1. So that means you will want this middle number to be 4 over 4, right? Okay, same for this. You will want this 1 over 3 to be the smallest number to get a 1. So you will want this to be 3 over 3. Okay, just from this, what do you think you should do?
Add the difference.
Add the difference between what?
The bottom number and the
Yeah, but
Bottom number and okay, what if it's 2 over 3?
I think add the bottom number plus minus 1.
Yeah. Okay, okay. So basically, yeah, like she said, this for this you add 2, which is equal to, okay, plus 3 minus 1, and then for this one you plus 4 minus 1. Okay, so for example 2/3, you do plus 3 minus 1, and then you will get 4 over 3, and then you will get 1. Okay? Okay, that's how you get ceiling. But anyway, back to the original question, that has nothing at all to do with ceilings. Okay.
Can you just like
Okay.
binary search?
exactly.
Hold on. Wait, let's just finish this, have a nice bookend to this. So this is, hold on. Equal to x plus y minus 1 over y. And then 4. Okay. Anyone have any other questions with this? No? Okay, cool. Anyway, back to this. Do you guys know the concept of binary search?
Yeah.
What criteria does it have to have for you to be able to do binary
It needs to be
search?
sorted.
Huh?
It needs to be sorted.
Sorted. What has to be sorted? What thing has to be sorted? What thing has to be sorted?
It needs to have like when you test a number, you need to know like whether it has to be smaller or larger for it to have the better solution. Like if it doesn't work, you need to make the time larger. But if it works, we're trying to minimize the time so we can reduce the time. So it needs to have like
Okay, that is an example for like a kind of a specific problem. It depends. Okay, so more generally,
Yeah.
you can think about like a function. You guys know functions, right? You should know. You should definitely know functions. So, when you want to do binary search, you input this x, and then you will get some kind of number, and then you will use that number to decide whether your left and right ends. You have this, and then you have this middle, and then you use the number that you get to decide whether you move the right side to the middle or the left side to the middle. Do you guys know the general concept?
yeah.
Yes? Do you know? Yeah. Okay, cool. Okay, so the criteria that this needs to, this requires to work is that f of x needs to be either increasing or decreasing, and it's non-strict. Why is it so tiny? Yeah. Non-strictly. Do you guys know strictly and non-strictly increasing, decreasing? Okay.
Non-strict is like you can be equal. Yeah.
Why is this so tiny?
And so non-strictly increasing is basically non-decreasing, and non-strictly decreasing is non-increasing.
So basically, if it's non-strict, it can go like straight. Flat? Yeah, it can be like that. You know, and then if it's strict, then it can only go up like This is not good. Frig. Like it cannot be flat. You know what I mean? This flat part, that means it's non-strict. It means that it can be equal. And then strict means that it has to go up. Okay? Okay. So basically, have you guys written binary search before? Okay. So yeah, okay, so for this problem, you binary search the time, and then you use the time to so here F, you input time, and then the output is how many products. Yeah. Okay. Output is how many products. So basically, if
So you just need to check any random value and
just a second, I have minor OCD. Okay, so if you don't have enough products, then that means you need more time. Okay? And if you have enough or too many products, then you could have too much or the correct amount of time. Okay? So when you find that you don't have enough, then you have to move the left end. You have to move the left end to the middle and then increase by 1, because you know that this is not enough. Okay? But when you find that you have enough or too many products, you have to move this right to this middle and not like this, because maybe it's actually the correct amount of time, the exact amount of time that you need. Okay, so I've seen some people write binary search like if
Oh, you mean the AP CS style, the CSA style?
yeah, like
That's
if
just horrible.
if products
one is kind of weird.
Yeah, it's just bad. Just ignore it. College
equals products needed, then like break. Do you guys know break? You know break, right? Okay.
No, what's breaking?
breaking means
Go
stepping on the
No, he
swing.
knows. He knows what it is.
切一半吗？
Oh my god, shut up. Okay.
What?
Okay, so this is
I'm gonna what do you call it?
Just breaking bad.
anyway.
Breaking
So
Bad.
this is how some people do it, but this is wrong. You know why?
Because it's awesome.
and then code
Okay, so say that each of the products, you have 2 machines, let's say, and then each of the machines takes 4, and then you need 2 products, and you check the time
they would pronounce that.
5. Okay, you check time 5, and then you will get I give up on this. I'm just going to use the text. Okay, so then you will get f t equals 5 equals 2. Okay, you guys know why, right? Okay, but then this will be wrong because you actually only need f t equals 4 for it to equal 2. So that's why even when you get the products number you get is equal to the products you need, it may still not be the correct time because you want the smallest amount of time that you can get to. Okay? Cool. That is
Equal 3.
yeah, I think that's it.
Equal 4. Then they run again.
Yeah.
Equal 1.
Okay, do you guys have any other
几
problems?
点？我2:13拍照的时候，哦，
Huh.
There's still time. Okay.
Anyway.
Side note. So for general binary search problems like this one, like you can observe that you do not actually compute the answer. Like if we sequentially find some time, and check if it exceeds or not, it's too slow, right? So, but the point is you observe that there is a relationship such that when you guess a time, when for some time, and then it exceeds, and any time that's bigger will also exceed, or for a time that it's does not exceed, any time that's smaller also does not exceed. So if you have this relationship, then you can eliminate half at a time, so you can do binary search. But another important thing is you will have to be able to know how to check, like our process for like t divided by ki floor. Yeah, so normally the format is you have a checking thing to see if exceed or not, and then use that to find your direction. That's normally how you do it for guessing the answer.
Okay, so let's talk about the time complexity. Yeah. Okay, what will be the time complexity of this algorithm?
Log
Log
and
2.
yeah, log.
And then, is that it?
And
What is n?
The
the,
like the t.
the n.
What is n?
The
The
range
maximum.
for the t.
2 times 10 to the 5.
No, I think it's the t.
Yeah, yeah.
Because we're
Yeah.
doing binary search on the time.
Yes.
Oh.
Yes, so the log n, and then where n equals the range of numbers to be searched. Okay, and then what?
She's just right t.
And the time to check
Okay,
for each value.
what is the time to check for each value?
Log value.
Hmm?
For,
Direct log.
for each
Like,
machine.
yeah, you need to check if the machine is possible to produce that amount of objects.
It's basically, remember this f of x, it's like how fast you can get this f of x result. Okay?
I think it's all n, like the number of machines.
Yeah, okay. Let's change this to t. No, let's do big T. And then times n. And then t equals, and then n equals number of, what? Oh, that's it basically.
Yeah, we're done right now.
Y times n.
Okay, because
You need to parentheses if it's
like this. Okay, so this is the time you need to do the binary search, right? And then for each binary search, you need to like find this f of x to check to tell whether you want to move the right side or the left side, right? Yeah?
Wait, let me think.
Okay, okay.
It's like when you have a loop or something, you fix the outside loop
How do I
and you find how many
exactly
times the
check?
inside loop does, and you multiply.
So right now you're asking if you know the time, then how many products will you get
Oh, yeah.
if you use this amount of time, right? Yeah, yeah. So then you check every machine. Remember we talked about this whole weird stuff at the beginning. Yeah, that is yeah. Okay, that's it.
你可以
Bye.
take my photo.
Bye.